Greetings, people. Teacher Alpha here. Today, we're looking at coordinate geometry, and this is the first video in this series of coordinate geometry. In this first video, we're going to learn how to find the gradient of a straight line in different situations. Now, without wasting much of your time, allow me to go right into the topic of the day. Now, the question is saying find the gradient of a straight line given that a straight line is passing through the points 1, 3 and 5, 12. Now, I would like to tell you that the formula for finding the gradient, okay, of a straight line is y2 minus y1 over x2 minus x1. This formula helps us to find the gradient in a situation where we are given coordinates such as these. Are we together? Okay. Now, with that said, to find our gradient, what we are going to do is we are going to label the coordinates given. So we have been given 1, 3 and 5, 12. Now, I wish to mention to you that the first number, okay, if you're given coordinates such as these, the first number that you're seeing there is called x, followed by y. Okay, just like there we have x and we also have y. So because this is the first x, we're calling it x1. That is the first y, we're calling it y1. That is x2 and that is y2. Okay, then we're going to follow what the formula says. So the formula says subtract y2 minus y1, which in this case is 12 minus 3. Are we together? Okay. Now, then we also have to subtract x2 minus x1. So we're going to say 12 minus, we're going to say 5 minus 1. 5 is x2, 1 is x1. So we're going to say over 5 minus 1. Then we go right ahead to subtracting. So 12 minus 3 is giving us a value of 9. 5 minus 1 is giving us a value of 4. Okay. Now, as your gradient, it's often recommended to leave your gradient as a fraction. However, it can still be changed into a decimal or a mixed fraction. So we have found the gradient for the first question here. And our gradient is 9/4 or 9 over 4, if you like. Okay. So we have found the gradient for the first pair of coordinates. So that's how you find the gradient if you're given two pairs of coordinates, such as question 1. Okay, let's look at question 2. Given that a straight line is passing through the points 7, 6 and 9, 12, find its gradient. Okay, we are also given coordinates here. So we need to use the coordinate formula for finding the gradient. So 7, 6, 9, 12. Okay. So what are we going to do? We know that that is x1, that is y1, that is x2, that is y2. So obey what the formula says. So the formula says subtract y2 minus y1. So our y2 in this case is 12. So we're saying 12 minus 6 over x2 is 9, x1 is 7. So 9 minus 7. So when we subtract 12 minus 6, we're getting a value of 6. 9 minus 7, we're remaining with 2. Now, how many pairs of 2 do we have in 6? There are 3. So, meaning 2 into 6 goes there 3 times. So in this case, our gradient is a whole number. So from question 1 and question 2, we're seeing that our gradient can either be a fraction or a whole number. Sometimes it can be positive, sometimes it can be negative. Okay. So this is how you calculate the gradient if you are given two pairs of coordinates, such as question 1 and question 2. Okay, now let us see how can we find the gradient. Now, supposing you're given a straight line, given that the equation of a straight line is 3y plus 6x equals to 12. Now, in this situation, we cannot use the gradient formula to find our gradient here. Rather, we're going to use the equation y is equals to mx plus c. Okay, okay. Now, meaning, if we have an equation like this, 3y is equals to, okay, sorry, 3y plus 6x is equals to 12. Now, if you have an equation like this, it means y must be made the subject. And you're going to notice that the letter m represents the gradient. The number next to the letter x is representing the gradient, in which c represents the y-intercept. The y-intercept. So what are we going to do then? So what we're going to do therefore is this. We are going to make y the subject. So let's go right ahead and do it. So when positive 6x crosses the equal sign, it changes to negative 6x. Remember, the one with the x should be next to the equal sign. Then this 12, it's positive in nature. Okay, remember, if you're given a straight line equation, you have to make y the subject in order to find the gradient, in order to determine the gradient. So at this point, what we're going to do, my friends, is we're going to divide the entire equation by 3. We are making y the subject because we are finding the gradient. So 3 into 6, we are getting negative 2x. Plus 3 into 12, we're getting a value of 4. So in this case, therefore, our gradient is this value that you're seeing there. So this is how you compute your gradient if you are given a straight line equation. So if you're given a straight line equation, you have to make y the subject. But if you're given coordinates, you have to use the coordinate formula for finding gradient. Okay, nice. Okay, all right. Okay, given that the equation of a straight line is 3y minus x equals 6, again, find the gradient. Remember, we said if we're given a straight line equation and we are asked to find the gradient, we have to make y the subject of the formula. We are making y the subject of the what? Formula. Remember this, don't forget. Y is equals to mx plus c. Our equation should look something like this, okay, in which m is the gradient. So let's make y the subject. So how do we do that? We take this negative x, let it cross the equal sign. So we're having 3y is equals to positive x. This 6 is positive in nature already, okay. Then at that point, we're going to divide the entire equation by 3. You cancel, you cancel. Now, I would like to tell you something. The number that is next to the letter x here is 1, but in mathematics, you know it's obvious that we don't indicate the 1 there. So in short, our gradient there is 1 over 3. 3 into 6, we're having 2. So therefore, our gradient for this straight line is 1 over 3. So we have learned how to find the gradient when you're given coordinates and when you're given equation of a straight line. Thank you very much.